We're given that the product of two numbers is 120, and we're trying to find whether that product has a maximum or a minimum, depending what the two numbers might be. If we think about it for just a minute, what are some pairs of numbers that give us 120? We can actually graph those pairs over here. So if x and y are the two numbers, and they multiply out to 120, then the numbers could be, let's say, of course, 120. But if we go to, if x is 4, then y, again, the condition, x times y are the two numbers. So x times y need to equal 120, so that would be 30. That's a pair of numbers that multiplies out to 120. Well, 6 divides into 120 20 times. And let's say, well, we could divide 8 into 120. We would get 15. We could divide 10 into 120. We'd get 12. We could divide 12 into 120. We'd get 10. And so forth. Let's go to 15. We divide 15 into 120. What do we get? We get 8. Well, we're trying to see what happens to the sum of the two numbers. Well, the sum of the two numbers here would be 34. 6 and 20 is 26. 8 and 15 is 23. We get 22. We get 22, and now we get 23. If we were to graph the sum of the two numbers, graph the two numbers versus their sum, we would have something like this. Okay, so that the sum of the two numbers, we're graphing x plus y versus x. Okay, make this specific. Here's x plus y, and here's x. Our graph is going to look like this. And it appears to have a minimum somewhere around 10 or 12. Now, maybe the minimum occurs at 10, and maybe it occurs again at 12, and maybe it occurs at some point between 10 and 12. It's not totally inconceivable that this thing could come over here like this. Instead of being a smooth curve, it might come over like this and have a big dip right here, for all we know. Probably not, because of the simplicity of the situation, but we can't discount the possibility. So what do? Well, we're going to set this up algebraically. We're not going to find the minimum. We're not going to find anything we can prove by just plugging in points. But we do this to get a feel for the situation. Okay, well, if x and y are the two numbers, then x times y is 120, so that y is going to be 120 divided by x. Now, if y is 120 divided by x, then x plus y is what? It's x plus 120 divided by x. So, in terms of just x, here's the sum. So this is the sum that we want to work out. Okay, and let's just be clear. If we plug x equals 4 in here, we should get 34, shouldn't we? Well, let's see. 4 plus 120 divided by 4. 120 divided by 4 is 30. Add 4, we get 34. Okay, now let's try 12. 12 plus 120 divided by 12. 120 divided by 12 is 10. Add that to 12, we get 22. Sure enough, we do get the same result. So this expression does tell us what the sum would be, the x plus y sum for every x value. Okay, well, so sum is now, we're going to call that, we've got to give that a name. We can't use y because we used x and y for the two numbers. The sum is a function of x. If we plug in x, we get the sum of two numbers that multiply out to 120. So that sum is expressed then by this expression, x plus 120 divided by x. And we want to find the maximum sum. How do we find the maximum sum? Well, we have an expression, we find its maximum. Okay, I'm going to say take s prime of x, the derivative. That is 1 minus 120 over x squared. We can find a critical point. Critical point occurs when s prime of x equals 0. 1 minus 120 over x squared equals 0. We can solve that easily for x. We get x equals plus or minus 2 times the square root of 30. So, and that's the only critical point. Well, actually, there are two critical points, plus and minus. But if we exclude negative numbers from this problem, from the statement of the problem, then there's only one critical number. Let's just say that there's only one positive critical number for this expression. Okay, is that a maximum, a minimum? Is it an inflection point? An inflection point being a point where the concavity changes. So we could have like this, and then the concavity changes like this, and we don't have a maximum or a minimum. Okay, first derivative test, second derivative test. Which one do we use? Well, if we choose the second derivative test, we're going to have to take the second derivative. The second derivative is, well, derivative of negative 120 over x squared is 240 over x cubed. So there's our second derivative, and that's positive for any positive value of x. Now specifically, it's positive for the x value 2 times the square root of 30. Also negative for x equals negative 2 square root of 30. But if we exclude negative numbers, we don't have to worry about that one. If we want to include negative numbers, though, we can do that. Okay, so what's our conclusion? Well, conclusion from the second derivative test, we have a positive second derivative, meaning that the graph is concave up. And of course, we can see that this graph is concave up. This fact that the second derivative is positive confirms what we believe we see from the graph, and confirms that the second derivative is always positive, meaning we couldn't have a dip down like here and then come back up, because to come back up we'd need a negative second derivative at some point. Our conclusion then is that we have a minimum when x equals a 2 square root of 30, and the minimum value is xy equals 2 times the square root of 30 multiplied by 120 over 2 square root of 30. And that gives us 120, and there's something wrong with that. I was careless. We were getting toward the end of class, I believe, when I wrote that down. Of course, x times y is not what we're trying to minimize. This just confirms that if x is 2 square root of 30, then x times y is 120, but that was our original premise, that the product of the two numbers is 120. So what we need is, we need x plus y, the sum of the two numbers. So I'm going to have to insert a plus here, change this to plus, and change a little bit of the other stuff. Okay, now if we do x plus 120 over x, the expression for our sum, we get this. X is 2 square root of 30. 120 then divided by x is 120 divided by 2 square root of 30. And we do the simplification. And divide the 2 into 120 to get 60. Then multiply numerator and denominator of this fraction by square root of 30 to get a denominator that's a whole number. Then put this all over common denominator, simplify, and we end up with 4 times the square root of 30 being the minimum, and that's approximately equal to 21.91. So we can illustrate that on the graph. We had 22 for x equals 10 and x equals 12. If x is 10 or 12, then y is respectively 12 or 10. The sum in either case is 22, so that the y values here are both 22. And I'm going to go off camera and draw just a little something on the graph. Okay, in yellow I sketched kind of a curve following our points. Now this is a hand-sketched graph. The graph might not look exactly like that, but we see that the graph does come down to 10, 12, and the point, 10, 22, and 12, 22. and appears to be on a downward path here and then a slightly upward path here, the minimum value is going to be just a little less than 22 according to the graph. And we've just calculated the minimum value. We see that it's 4 times the square root of 30, which is approximately 21.91. We also note that the minimum occurs when x is 2 times the square root of 30, which is approximately 10.95. If this graph was a parabola, and it doesn't appear to be a parabola, it doesn't appear to be symmetric, it seems to go up more slowly here than it came down here. If this was indeed a parabola, then the minimum would occur halfway between 10 and 12, which would be at 11. It occurs at 10.95, just a little bit less than 11. This at least confirms that this graph doesn't have the kind of symmetry that we would have with a parabola. In fact, there's a complete absence of symmetry in this graph on this side of the axis. Now, if we graphed it for negative x, we would have this graph that turns out to be symmetric with respect to the origin, so we'd have a symmetry there. We'd have a graph that looks something like this down here.